Okay, let's pick up where we left off from the last video break. Let's get started. The first consideration when looking at networking is deciding, is the equipment you're going to build out the system with, is that going to go on an existing company or corporate network, or are you able to build out a parallel security network to any other type of network the customer may have? What this involves is being able to speak very intelligently and effectively with that customer's IT department, not only to convey to them the requirements you have of the devices putting on to their network. In other words, do you need PoE for the cameras? Are you going to be using multicast? What type of IP scheme do you need? You need to effectively communicate with them, but you also need to understand that the restraints they're going to put on you, can you deploy the system effectively based on those constraints? And so what we've found in general is that our customers that are most successful are the ones that understand networking enough to be able to really communicate with those IT departments, not only to understand the needs, but also ultimately to try to convince them to build out a parallel security network. That allows them the freedom to have product selection for the switches they need and being able to put them in harsh environments, but also it allows them to deploy the devices in the fashion that that equipment needs, thus creating a very strong, separate network that they can implement and also manage on an ongoing basis. The next consideration is deciding what environment is this equipment going to go into from the networking component standpoint. Are they going to go in a nice climate-controlled IDF closet, or are they going to go in a small Hoffman box on the outside of a building, bottom of a pole, or in the bottom of a parking garage? That's going to lead towards a very significant decision in product selection. Can you use a commercial-grade equipment to put it in an indoor environment, or do you need to use a hardened device that's going to actually operate and last in an outdoor environment? Port counts also become very important. Obviously, you can figure out how many ports you need with the initial system. So if you're adding 6 or 7 cameras here, you need to make sure you have enough ports at that location where they're all going to come back to the same network switch. However, as I mentioned earlier in part 1, customers are often adding devices more and more frequently. So you definitely need to plan for scalability and additional devices to come onto the system in the short term and the long term. So having expansion ports on whatever switches you put out in the field is also a very important aspect. Also, with bandwidth, you need to understand how much bandwidth you're putting onto the network and then select the appropriate switches with the appropriate backbone ports to carry that traffic. So what this really does is stress the importance of writing down and drawing out the system that you're designing and implementing. So understanding what switches you're putting in which location, what you're attaching to that, and what network requirements those devices have, and being able to add that all up and calculate how it, and take a look at how it's going to flow across the network to make sure you have enough bandwidth to handle today's equipment as well as any expansion that you might use in the future. Cable distance is also a significant thing to take a look at. In the old days of analog, you were limited to 750 feet up to 1,000 feet for a single camera over coaxial cable. But today's IP environment, you're limited to 328 feet, that magic 100 meters of category 5 and 6 cabling. So you encounter that distance limitation more and more frequently. For instance, a lot of people are moving towards fiber optics to carry the signal beyond that 100-meter distance limitation. If so, you need to obviously have fiber optic ports in the switches and potentially use media converters out in the field as well. But even when it comes to fiber optics, there's a significant distance limitation you need to take into account. And that is gigabit Ethernet speed, which is 1,000 megabits per second, over multimode fiber. That typically does not perform very well. The IEEE standard says that you require 2 fibers to create a point-to-point link for that, and you're limited to as little as 220 or 300 meters. Now also what you need to decide, what type of switch you're going to use. Are you going to use an unmanaged switch or a managed switch? And if you're using a managed switch, what layer? Layer 2, layer 3, etc. And this is a significant decision. If you need security, if you need to handle VLANs, if you need to connect switches in a ring, if you need to use any other type of high-end protocols, that's going to dictate the requirement of a managed switch. Unmanaged switches, you can't connect them in a ring. They don't handle multicast. They don't handle VLANs, things like that. So that obviously is going to add a layer of complexity to product selection, product implementation, and the support and use of the system over time. Next, you need to consider the requirements of your edge devices. Your cameras, are they going to be using multicast? Do they need PoE? How much bandwidth are they going to put onto the network? All of those things you need to consider because they relate to the networking layer, and you need to pick the switches appropriate to be able to handle that. And so what you can probably start to see here in this design consideration slide is that there are a lot of nuances and a lot of design considerations to think about in order to pick the right product, implement it properly, and get it to work. So really what it's becoming is it's much more about these subtle protocols than it is about those physical constraints that we had in the analog days. We're no longer connecting devices necessarily in point-to-point fashion and worrying about the electrical. 1 volt peak to peak, 750 feet maximum over RG59. Now we're talking about all these really subtle and abstract concepts like the specific protocols, how you connect them, bandwidth calculations, all those different types of things. So the layers of complexity with designing and implementing an IP network become significant in this option number 2 when pulling in a full network solution when migrating from analog to IP. So let's start to take a look at the actual tools of the trade that you can use to deploy a security network. One of the first items that people often migrate to is a simple media converter. And its function is to take in a copper Ethernet signal and convert it over to a fiber optic cable signal. And the real reason most people want to do that is to exceed the distance of 100 meters that signal can transmit over copper. So this has a copper connector on this side, a fiber optic connector on this side. Now, ComNet manufactures a large array of media converters to fit any type of situation you may have in the field. Meaning, if you already have an analog camera over fiber optics, you already have a particular type of fiber. That fiber has a connector on the end of it, and you're already using some type of power scheme for that existing camera. Well, ComNet has the right media converter for that application. So we also manufacture a line of unmanaged switches. These are 4/8 ports. They're very versatile because they can have either copper or fiber-based ports using SFP Optics. Many of the ComNet Ethernet devices utilize small form factor pluggables, or SFPs. These devices are actually your laser transmitter and receiver for transmission over fiber optic cabling. We sell 37 different SFPs for a variety of different variables. They come in 1 fiber options, 2 fiber options, 100 megabit speed, gigabit speed, and distances all the way up to 120 kilometers. And the way these work is that you can plug them into either an unmanaged switch, a media converter, or a managed switch, and just by sliding them in, they're able to be used. No configuration necessary. And the SFP is an optical standard, which means that a ComNet SFP is able to communicate over fiber optic to another manufacturer's SFP, such as Cisco or HP or someone like that. So there's vendor neutrality in Ethernet networking, and that applies down to the fiber optic connectivity as well. Let's take a look at a simple application for media converters. So in this case, you have a remote camera more than 100 meters from any network drop. And all you're going to do is simply connect that camera to the media converter using Cat5 or Cat6 cabling. Then it transmits over the fiber optic cabling to another media converter, which converts it back to copper and then is plugged into a common network switch. Obviously a very simple concept to deploy when you have one device. When you have multiple devices, it adds a layer of complexity with installation, meaning you have all these devices that you need to shelf or wall mount. You also have all this cable management down at the switch end that you have to neatly perform. So a second option is to move towards a rack-mounted media converter option. ComNet manufactures single or dual-channel media converters that can be rack-mounted into our C1 card cage and then still punch down into the switch. So you still have all the points of failure, it's a neater installation, and you have all the cable management still to deal with. So a third option is to utilize a ComNet modular switch, which can have up to 24 different fiber optic ports. So in this case, you have all these remote devices over a remote media converter directly connected right into the switch, and then depending on the switch that you choose, this one has 2 gigabit uplink ports to either connect to other network components or to uplink into a larger network. This solution is obviously much easier to implement. There are fewer points of failure, and it represents an almost $7,000 cost savings from list price on these devices. Okay, we'll take a short video break here. We'll meet you back for the next part of the video.